In this problem, we are being asked to factor by grouping if possible, and they gave us the option to click that little radial button if it's not possible. Let's see what we can figure out. I'm going to first start by just writing this problem down so I can play with it instead of just look at it and try to figure out what's going on. When we factor by grouping, our first step, after we look to see if there's a GCF across everything, and there is not. This has a Z each, but there's no Z's here. This one has an X each, but there's no X's there. Here's a 2, here's a 2, and here's a 4, but there's no factor of 2 here. So we're going to go straight to that next thing is to put parentheses around the first 2 terms, put parentheses around the last 2 terms. This did not automatically become multiplication. So it was important to include this sign inside the parentheses, but remember that this did not turn into multiplication. Now I'm looking for the GCF of the first 2 terms. If I look, they do both have a Z in common. So Z is my GCF of those first 2 terms. So I don't forget, I'm going to write it outside my parentheses. I'm dividing by Z. That's how we factor out a GCF. So my leftovers are A minus 2B. Looking at the last 2 terms, they both have an X in common, but they have more. They both have a 2. 4 is 2 times 2. So they have 2X in common. Again, I'm going to come down here and write my GCF so I don't forget about it. And then go back up and divide out that 2X. 2 divided by 2 is gone, and X divided by X is gone. 4 divided by 2 is 2. So this one, after I divide the 2X out, I have A minus 2B. This is a good place to check and say, well, we know we are on the right track because when I divide a GCF out of the first 2 terms and divide a GCF out of the last 2 terms, I should have matching binomials. And I indeed do. So I should have brought that plus sign down. I'll do that now. And since I did just verify that I have a binomial GCF, I'll make myself that note. And just like before, I'm going to write it down so I don't forget about it. And now I'm going to write whatever's going to be left over after I divide it out. So I divide this term by A minus 2B and divide this term by A minus 2B. A minus 2B divided by A minus 2B. My leftovers are Z plus 2X. So that is factored. I now have 2 binomials multiplied together. So it is indeed a factorable problem. I'm not going to click that radial button. Instead, I'm going to type this into my answer box.